Here is the next experiment trying to demonstrate whether or not it requires 4 units of energy to go twice as fast or to stretch the rubber band twice as much. So here we have the pendulum once again. I'm going to drop it from here. This is 1 height, 1 unit of energy, or 1 velocity. I'm probably going to place the timer here once again. We're going to measure how much the maximum stretch is. Then I'm going to release it from 4 times the height, so making sure that it will go twice as fast, and then see how much the maximum stretch is. If the maximum stretch is twice as much, then there is an agreement for both parties. Then it means twice the velocity equals twice the amount of stretch. The only difference is conventional science says it requires 4 units of energy to go twice as fast or to stretch it twice as much. And the opposition says no, it only requires 2 units of energy to go twice as fast or to stretch it twice as much. So how are we going to prove which one is correct? Well, this is 1 unit of energy. Okay, so first we have to know the maximum stretch when it goes twice as fast. That's the distance we want to achieve. And so first we check the amount of stretch with 1 unit of energy. So let's say it stretches 1 centimeter. Then next, I'm going to pre-stretch it, fix it to that exact location. So I'm going to stretch it 1 centimeter backwards. Then I'm going to repeat the same pendulum drop or another unit of energy and see how much further it stretches. Will it stretch another centimeter or will it be less? According to conventional science, it will be less. It will only be 1.441 times as much stretch. All right, and then I'm going to, for the third trial, I'm going to pre-stretch it, fix it to that new location once again, and then repeat the same pendulum drop, another 1 unit of energy, and see how much that it stretches extra. All the way to the total amount of maximum stretch as it went when it went twice as fast. And normally it should require 4 units of energy to make it to the total amount of stretch when it goes twice as fast. Do you understand what I mean? You will see what I mean. Okay, so now I'm going to check what the timing is for the 1 height, the 1 velocity. So I bring it up till here. Now I have to 0 it, so sorry, I have to do like this. All right, so 0, and then I let it go. Okay, then we have to go to the memory. It says 92, so that's the velocity. All right, so 0 it again. Sorry for the continuous camera perspective change. Let it go. Memory 92 again. Okay, 0 it. There we go, 0, and let it go. Memory again. It says 93. 0 it again. I'm sorry for giving you a headache. Memory 92. I think we have consistent results. One more. 0 it. There we go. Memory 92. All right, so it's 92.
Here is the slow motion footage of the 1 velocity. The results show that the maximum stretch is around 2 centimeters.
All right, now, so to double the velocity, the timing should be, so 92 divided by 2, it should be 46. So I pulled back the speaker, and so this should be twice the velocity. So let me put it on, turn it on, and then, 0 it. Okay, so it's 0, here we go. Memory, it says 47, right? 0 it. There we go. Okay, memory 47. 0 it. Reset. So 0, here we go. Okay, memory 47. 0 it. Last one. 48. So yeah, this should be around twice the velocity.
As can be seen, when it goes twice as fast, there is a maximum stretch of 4 centimeters, which is precisely twice as much. This means that both parties agree. When you double the velocity, you double the amount of stretch. So now, does this require 2 units of energy or 4 units of energy?
Okay, so the distance between the release point at the speaker and the rubber band is always a little bit above 9 centimeters. That's the 1 unit of energy distance. So that should always be the same. Okay. Alright, so now I finally managed to pre-stretch the rubber band to the location of the maximum stretch of the one velocity, which is 2 centimeters. As you can see, it is fixed at the 2 centimeter mark. And now the distance between the rubber band and the dropping point is around 9. Hold on, I can't see anything. Should be around 9 centimeters. A little bit above 9 centimeters. Can you see that? Hopefully I can't see anything. So that should be the same energy input, and I'm going to release it and see how much further the rubber band stretches. Okay. Yeah, so I also forgot to move the entire setup, the pendulum, more to the front, such that it will be right next to the rubber band. It's at rest right next to the rubber band. You also have to make sure that that happens each time.
So here is the slow motion footage where the rubber band is pre-stretched to the 2 centimeter mark. I now will drop the pendulum, giving it another 1 unit of energy. The results show that the maximum stretch reaches the 3 centimeter mark. This is roughly 1.5 times more stretch. However, according to the draft science, it should have reached the 4 centimeter mark, but that didn't happen. So now I will pre-stretch the rubber band to this new location and make sure it is fixed at the 3 centimeter mark.
Okay, so as you can see, the rubber band is now pre-stretched to the 3 centimeter mark. And so we're going to give it another unit of energy and see how much it stretches further.
As can be seen, the maximum stretch reaches the 3.5 centimeter mark. According to conventional science, this should be 1.73 times the initial stretch. So 2 centimeters times 1.73 equals 3.46, and my result is 3.5. That is pretty close, I would say. And so once again, we are going to pre-stretch the rubber band to this new location and make sure it's fixed at the 3.5 centimeter mark.
And as you can see now, the rubber band is pre-stretched to the 3.5 centimeter mark. And now let's repeat another unit of energy.
And now we finally have reached a 4 to 4.1 centimeters mark, which was the maximum stretch when the pendulum was dropped with twice the velocity. So conclusion, 1 unit of energy gave us a maximum stretch of 2 centimeters. 2 units of energy gave us a maximum stretch of 3 centimeters, which is 1.5 times more stretch, and the prediction is 1.41 times. 3 units of energy gave us a maximum stretch of 3.5 centimeters, which is 1.75 times more stretch, and the prediction is 1.73 times. And 4 units of energy finally gave us a maximum stretch of 4 centimeters or 4.1 centimeters, which is very close to twice as much stretch as predicted. This once again demonstrates that it requires 4 units of energy to go twice as fast or to go stretch the rubber band twice as much.